So now that we've graphed these equations, we can identify which ones are going to be lines. Let's take a look now at some shortcuts for graphing lines. First thing I want to do is I'm just going to graph some of the most basic lines that I can think of. The absolute most basic line is just this one, y equals x. Doesn't have any powers, nothing, not dividing by x, anything like that. So we know that's going to be a line. So if we graph it, let's just pick some numbers. Let's say x is -3. What's y going to be? -3, right? Because y equals x. So that's a point right there. If x is 0, what's y going to be? 0, because y equals x. If x is 2, what's y going to be? 2. So we get this nice line that goes through the center of our graph. Remember, we called the center the origin. Kind of a 45-degree line right across the corner to corner like that. Well, that's the simplest equation for a line that we can think of. What are some things we could do that would be more complex? Well, we could maybe try y equals x plus 2. So now whatever x is, we have to add 2 to it to get y. So now if x is -3, what's y? -1, right? -3 plus 2 is -1. If x is 0, y is 2. If x is 2, y is 4. We get a line here that's parallel to that first one, but what's changed? It's moved up 2 spots. Hence plus 2, right? Now before we graph this, what do you think would happen if I did this? Y equals x minus 3. Probably move down 3. Let's check it out. If x is 0, y is 0 minus 3 is -3. If x is -1, y would be -4. If x is 2, y is -1. 2 minus 3 is -1. And it is. It's parallel to the original line. That black line has just moved down 3 spots. Well, okay, so we can add to move it up. We can subtract to move it down. We can also multiply. Y equals 2 times x. Well, now if x is -2, what's y? -4. If x is 0, what's y? 2 times 0 is 0. If x is 2, y would be 4. 2 times 2 is 4. It's back to going through the origin, through the center of the graph again here, but now it's steeper. So multiplying makes it go steeper. What if I wanted it to go shallower? Try to divide. There we go. How about we're going to do this though? Instead of dividing, we know that multiplying by 1/3 is the same as dividing by 3. So now if x is -3, y is just -1. If x is 0, y is still 0. 1/3 times 0 is 0. If x were 3, 1/3 times 3 is 1. So we do get a line that is shallower like that. So we can move it up and down by adding or subtracting. We can make it steeper or shallower by multiplying or dividing. But you'll notice all these lines, as we go from left to right, are going up. None of them go this way. How do you think we can make them go that way? -2x. Now, if x is -2, y would be +4. Because -2 times -2 is a +4. Of course, if x is 0, y is still 0. If x is 1, what's y? -2. So there it is. It goes down and it is steeper. So there's really only 2 things that can happen to a line. All lines start out at the center in the origin here. But this number here, what's added or subtracted, moves it up or down. That -1 means it moves down 1. The number that multiplies the x makes it steeper or shallower, or makes it go down instead of going up. that number that multiplies the x is called the slope. And we're going to discuss that a little bit more in just a few minutes. So if I wanted to graph this equation here, all I got to do, the minus 1 says I'm going to start out here at negative 1, and the 3 says I'm fairly steep. Something like that. Oops. Pretend that's a line. There we go. My drawing skills are horrible, as you will have probably already seen. Let's explore that concept of slope a little bit more. Slope is actually a ratio. Slope is defined to be a rise over a run, a ratio or a fraction. So if I have a slope of 2/3, what that means is from a starting point, any starting point, it's going to rise 2, goes up 2 units. And it's going to run how many? 3. So it's going to go over 1, 2, 3. Run is always left to right. So the line goes through those 2 points, like something like that. So let's go back up here to this one. We said we needed a starting point. Do we have a starting point? You bet. Negative 1. We started right there. Now the slope is 3. Well, that's not a rise over run. How do we make it into a fraction, though? 3 over 1. Yeah. So what that's telling us is from the starting point, we're going to rise 1, 2, 3, and run 1. There's our second point. There's your line. So let's take a look at some examples. Y equals 3/4 x plus 2. Where are we going to start? Positive 2 right here, plus 2. So 1, 2. From there, our slope is what? 3/4. So from this point, we're going to rise 3 and run 4. There's my second point. There is my line. So this one, where do I start? Negative 3. Right there. Now it's a slope of 2, but I'm going to change that into a fraction by making it 2 over 1. So from this point, I'm going to rise 2, up 2, and over 1, right there. How about this one? Where do I start? Okay, yeah, the 3. Even though it's in the front, we're used to it being at the end, but it's in front this time. It's still 3 is being added to the variable. So we're going to start here at positive 3. From there, what's our slope? 1/2. So from that point, we're going to rise 1, run 2. Very good. How about this one? Where are we going to start? Plus 1, right there, because it's the 1 added to it. And from there, we're going to go... Now, the slope here is negative 2/3. So we're going to go down 2 over 3. Notice the positive or negative only goes with the rise. The negative means we just go down instead of up, but we still run left to right. Always left to right with the run. So there we go. Any questions? So in your notes, I want you to graph a couple. Try those 4 in your notes quick. For the first one, where do we start? Positive 5. So right there, and from there we go. Perfect. We make this negative 3 over 1, so we go down 3 over 1, right there. How many of you had that one? Any questions on how we got it? Next one, the green one, where do we start? Negative 2. And from there we go up 1 over 3. Purple one, where do we start? Negative 3 right there. And from there we go down 3 over 2. Because we got negative 3 halves. The red one, did anybody catch the issue there? There's 2y. We're used to just y. In order to use our shortcut to graph, it has to be y equals. It can't be 2y equals. So this one is going to require some changes. I have to get rid of the 2. The 2 is attached to the y because it's multiplied. So to get rid of it, we have to divide. When we multiply or divide an equation, we have to multiply or divide every piece. So the 2y divided by 2, that divides out the 2, leaving us with just y. Over here, I'm going to treat this as a 1x. 1x divided by 2, well, there's a little trick. 1 divided by 2 times x, 1/2 x. How about 4 divided by 2? It's 2. So technically that one starts at 2, and from there goes up 1 over 2, right there. So we have to make sure our equation is in that form, y equals. There's nothing else with the y. So for this one, what is the issue with it? It's y plus 3. Good. What do we have to do to fix it? We're going to have to subtract 3 to get rid of that, leaving us with just y. 3 was added. We get rid of it by subtracting. Now, when we add or subtract, we only have to add or subtract to one piece on each side. So on the other side over here, I can't take 3 away from 2/3 x. But I can take a 3 away from a positive 2. 2 minus 3 is negative 1. Now I'm going to pause here. Does everybody see why I couldn't subtract 3 from 2/3 x? Because that's an x and this is just 3 ones. They'd have to both be x's to subtract them. So now we have y equals 2/3 x minus 1. We start at negative 1 and we go up 2 over 3. in your notes, adjust that one and try to graph it. We're going to go over it in a second. What do we have to do to it? Well, the 4 is multiplying the y, so we have to divide by 4. So we have to divide by 4 over here, and remember, when we multiply or divide, we have to do it to every piece. So 8 divided by 4 is 2. Negative 2x divided by 4, that'd be a negative 2 over 4x. Negative 2 over 4 reduces to negative 1/2 x. Good. So now where do we start? Positive 2. And from there we go down 1 over 2. Good. There we go. This is where I wish I had a graph template just to scroll down and keep graphing, but I could, but then I have to switch back and forth, and it's just a pain. It's easier this way. My sketches are close enough. Something like this now. Obviously, y is not by itself again, but we've got a little more work that we're going to have to do to get it by itself. What's that? Oops. I should probably put a y in there, shouldn't I? Yeah. How about that? Is that better? Y was by itself because y was off somewhere completely wrong. Okay, there, that should be better. Yeah, they're all vowels. So what do we do here? We got to get y alone. What's keeping it from being alone? The 3 and minus 1. So just like solving any other equation, what do I have to do first? I'm going to add the 1. Get rid of that. Gives me a 3y. Over here, when I add or subtract, do I have to do it to the whole side or just one piece? One piece. When I multiply or divide, I do the whole side. Add or subtract, it's just one piece. And I'm going to add the 1 to the 5 because those are both just whole numbers. So the 2x doesn't change. 5 plus 1 is 6. And now I need to get rid of the 3. How is it? When I add or subtract, yeah. That's why I could add the 1 to the whole, that's a whole number negative 1, or an integer negative 1 to another integer 1. I'd add the integer 1 to the integer 5. When I add or subtract, I have to have the same name.
Okay, but what about my 3y and my 2x? They're not the same.
Yep, I'm not going to try to combine them, though. But when I divide, I don't need the same name. So I'm going to divide by 3 to get rid of that 3, leaving me with y. Dividing by 3 over here. What's 2x divided by 3? 2/3 x. Very good. What's 6 divided by 3? Positive 2. So, for that one, where do we start? 2, and then from there, up 2 over 3. So, when we have this, where it's 3y minus 1 or whatever is there, it's just like solving any of our other equations. We've got to add or subtract first and then multiply or divide. How about this one? We have to get the y by itself. So we're not even concerned about the fact that this is an x here. We're just trying to get rid of it. What's happened to y? Y has been multiplied by 2 and 3x has been added to it. So we're going to subtract 3x. It's going to be gone. Leaving us with 2y here. We have to subtract 3x from the other side. Can I subtract it from the 8? No. So what I end up with is 8 minus 3x. I can't really combine anything. I still have to do it to that side, but there's nothing I can combine it with. Now what? Divide by 2 makes that go away, leaving me with y. Dividing by 2 over here, what do I get? Perfect. 8 minus 2 is 4. Negative 3x divided by 2, negative 3 over 2, x. And of course, that means we start at what? 4. 1, 2, 3, 4. And from there we go down 3 over 2. There's our line. What do you think? Still more fun than start sticking the eye? I'm going to have you guys try a couple. Try those two in your notes. For the first one, what do we have to do to adjust it? Start out subtracting 5. Now, when we add or subtract, it's the whole side or just one piece? One piece. So this is 3y equals 2x minus 6. And then divide by 3. Y equals 2/3 x minus 2. So we start at negative 2 and up to over 3. Down here, what do we start off with? Subtract 5x, which gives us what? Perfect. Negative 2y equals 4 minus 5x. Now what? Divide by negative 2. Y equals negative 2. 4 divided by negative 2 is negative 2. Negative 5x divided by negative 2 is a positive 5 over 2x. So we start at negative 2 and we go up 5 over 2. What do you think? Okay. How about that one? How do we graph that? Well, what's our slope? We can think of it like this. It's y equals 0x plus 5. Because 0 times x is 0. That's the same thing. So we're going to start out at positive 5, right? And this is 0 over 1, which means we rise 0, run 1. It's a flat line at y equals 5. It has a slope of 0. So if I have y equals negative 2, it's going to do what? Flat line at negative 2. Right there. Everywhere on that line, y equals negative 2. Here, x might be negative 8, but y is still negative 2. Here, x might be 5, but y is still negative 2. It doesn't matter what x is on that line, as long as y is negative 2. It's a flat line. Now, a little bit harder to conceptualize is this one. X equals 3. There is no slope or y-intercept there because there's no y equals. But from what we've seen with y equals 5 and y equals negative 2, what do you think x equals 3 is going to do? Yeah, we go to x equals 3, it's going to be a vertical line, up and down, at x equals 3. Or how about x equals negative 7? Oh, 1, 2, 3, 4, 5, 6, 7. There we go. What's the slope of that line? The slope does not exist. This is the vertical line. There is no run. It's all rise, no run. The way you can think of it is this. I can pick 2 points. Well, the rise is going to be positive, but the run's going to be 0. And can we divide by 0? No, we can't. Now, here's how I remember this. Anybody here like to ski? Belle. Okay, we're going to pick on Belle. Sorry for this in advance, Belle. But you can handle it. Belle likes to ski. Of course, a moderate slope like that is a little bit of fun, right? A lower slope like this is less fun, right? So lower slope, less fun. Steeper slope, scary but more fun, right? How about on a flat line like this? 0 fun, right? So 0 slope. Slope equals 0. How about on a hill like this? By the time Belle gets to the bottom of that slope, Belle is no longer exist. I told you I'm going to pick on you a little bit.
But that's okay. Between no fun, okay fun, pretty fun, and a lot of fun, I had a lot of drinks, so by the time I got to don't exist.
You don't care. There we go.
Less painful.
There's a new quiz due tomorrow. That's Wednesday at 11:59 p.m. A new homework due on Thursday at start of class. I believe there's only like one more.
7 more questions.
That's not that bad. I believe there's only one more quiz and one more homework assignment left. There may be 2 homework assignments. 2 homework assignments. We're going to start, after today, we're going to do a little bit on like statistical graphs, like picture graphs, line graphs, bar graphs. Then we're going to talk a little bit about statistics, analyzing data. Now, we're only going to have 2 classes to fit it in because a week from this Thursday will be our Unit 4 test. And then, of course, the final test will be on the 15th. So only 2 more lectures left. Lucky you.